All right, here we go, video 2. So in this lab, we don't actually know what is created. Maybe it was sodium hydroxide, but maybe it's sodium oxide. We don't know. So what we're doing is we're going to do this calculation 4 times, one for each possibility. And we're going to look at all those grams of product, and one of them is going to match what we found in lab. And that'll tell us what the right answer is. So here we go. We're going to do this one together. I'm going to ask you questions. You're going to give me the answers. Oh, hey, look at that. I already have the molar mass of sodium bicarbonate done because we did it before and it's the same thing. I already did grams of reactant to moles of reactant because it's the same thing. Again, use your number, not my number. So here's my question for you. What's the molar mass of sodium oxide? Okay, so here's how I would do this. Well, I have 2 sodiums, and I got 1 oxygen, and that's going to give me, let's see, 2 times 22.99 equals that, plus 15.99 equals that, 61.97 grams per mole. All right. Next question. I need to go grams to moles. Oh, look, I already did that. So my question for you is this. How many moles of reactant do I have in this problem here? Yeah, I mean, it better be the same thing as before. All right, so I'm now going to multiply it by my mole ratio. Okay, so here I am at my balanced equation. In order to find the mole ratio, I need to know what those numbers are. So let's balance this. How many sodiums are on the left? How many sodiums are on the right? Okay. How many hydrogens on the left? How many hydrogens on the right? Okay. How many carbons on the left and how many carbons on the right? Oxygens on the left and oxygens on the right. All right, well, there's 3 oxygens there, and there's, this is tricky. 1, 2, 3, 4 oxygens on the left. Oh man, this is brutal. Okay, so I'm going to start here. I want 2 sodiums on the left. So what number do I put here so I end up with 2 sodiums? Yeah, 2. So now look at this. I now have 2 sodiums on the left, but I also have 2 hydrogens on the left. I also have 2 carbons on the left, and I have, 6 oxygens on the left. Okay, so my sodiums are balanced, my hydrogens are balanced, my carbons are not balanced. So how many carbon dioxide do I need to make the carbons balanced? Yeah, I need 2. Okay, so that means that now I have 2 carbons, and I have 1, 2, 3, 4, 5, 6 oxygens. Okay, so sodium is balanced, hydrogen is balanced, carbon is balanced, oxygen is balanced. Oh, okay, so this is a 1 then, and this is also a 1. So my molar ratio is 1 mole of that is made from every 2 moles of that. Oh, I make half as much as I start with. I only end up with half as much. Okay, so my mole ratio then is going to be 1 mole of product over 2 mole of reactant. Now, my question for you. What's that answer? Okay, so 0.0595 times 1 equals that, divided by 2 equals that. And I get 0.02975 moles of product. Okay, well then, wait a second. Now I got to go from moles of product to grams of product by multiplying by the molar mass. What's the molar mass of my product? Yeah, you already found it. All right, so that times a 61.97 equals 1.84. So now I could look and say, okay, is my final mass 2.38? No. Okay, so it can't be sodium hydroxide. Is it 1.84 or something really close to it? Yes. Then this is my answer. If no, well, I gotta keep working. Now, the last ones I am leaving for you. You're gonna do the same exact steps that I just did with number 3 and with number 4. If you would like, I am posting a video that is literally just me asking you the questions to, help you figure out what's going on. All right, hope that helped.